The U.S. Army just successfully tests its Scramjet-Powered Hypersonic missile. According to recent Lockheed Martin and DARPA press releases, the United States successfully tested a Scramjet-Powered Hypersonic missile last month in flight speeds of more than Mach 5 or around 3,838 miles per hour are possible with hypersonic missiles, a new generation of highly developed weaponry. These missiles are nearly impossible to intercept with current missile defense technologies due to their speed and mobility. Is America really losing the hypersonic arms race, or everything has planes from the currently famous in the air to the most advanced around the world? In addition, for the latest episodes we'll be covering all military defense news, so stay with us to lead to this video so you don't miss out on any of this information. And before we proceed, don't forget to subscribe to our channel and click on the bell icon so you don't miss out on any of our amazing videos in the future. For the first time since the early Cold War, America is falling behind its international rivals in a race for technological advancement with significant military and diplomatic ramifications. One of 6 new technologies identified by the Pentagonists having the potential to determine how future wars are resolved as the use of hypersonic weapons. But as long as the United States rivals are developing hypersonic missiles, its own efforts will continue to fail. What gives then? How is it that the Russian military, which receives just $61 billion a year, already has 2 hypersonic weapons, while the United States, with a defense budget of over $700 billion, is unable to do the same? Well, the reality is complicated, as truths often are, and as you'll see in today's video, the mere question might not accurately capture the true nature of the hypersonic weapons race we are currently engaged in. And just recently the United States seems to be the front-runner in developing scramjet-powered hypersonic missiles, despite the fact that China and Russia already have hypersonic boost-guide weapons in use. The hypersonic air-breathing weapon concept, or Hawk, a high-speed weapon that uses cutting-edge new scramjet propulsion to achieve hypersonic velocities, was successfully tested by the Lockheed Martin variant, the Defense Advanced Research Projects Agency, or DARPA, Air Force Research Lab, or ARFA. Lockheed Martin and Aerojet Rocketdyne collaborated to develop this weapon, according to a report published in January. Eric Sheriff, Vice President of Hypersonic Strike Programs at Lockheed Martin Space, hypersonic systems provide a combination of speed, maneuverability and operating altitude that enables highly survivable long-range capability for the rapid defeat of time-critical, heavily defended and high-value targets. The Hawk missile initiative, led by DARPA, has already achieved 2 successes, but this is the first one to use a Lockheed Martin scramjet propulsion system. An Hawk missile made by Raytheon and propelled by the scramjet from Northrop Grumman had previously been tested successfully. No country has ever successfully fielded an operational system, weapon or vehicle powered by scramjets, despite the fact that the technology has been studied for decades, according to Andrew Tippy Nadler, Program Manager for the Lockheed Martin Hawk and DARPA's Tactical Technology Office. This Lockheed Martin HAWC flight test successfully demonstrated a second design that will enable our warfighters to choose the appropriate capabilities to dominate the battlefield in a competitive manner. These accomplishments raise the technological maturity needed to convert Hawk into a service program. Of the Hawk may maneuver in midair to avoid being intercepted just like conventional cruise missiles do. It follows a trajectory that is relatively stable, like that of an airplane. The missile, which was reportedly launched from a B-52 Stratofortress off the coast of the West Coast, was originally propelled by a conventional rocket booster before later being propelled by a Lockheed Martin scramjet. Once it reached a speed that allowed for the scramjet, no information on the Hawk's top speed range is yet to known. However, reports suggest that this recent test was carried out at moderate hypersonic speeds just above Mach 5 at an altitude greater than 65,000 feet for more than 300 miles. 300 miles will be covered in about 5 minutes at current speeds, with Russia, China and the United States all scrambling to develop and field various types of high-speed weapons. Hypersonic missiles have been the focus of what some are referred to as a modern-day arms race. Hypersonic boost glide vehicles and scramjet-powered cruise missiles are the 2 main types of contemporary hypersonic weapons. China and Russia both currently have hypersonic boost glide vehicles in use, but no countries yet to perfect screenshot technology to deploy a hypersonic cruise missile. David Berganini, Vice President of Hypersonic at Strike Systems at Lockheed Martin Missiles and Fire Control, told us in January that traveling at speeds of Mach 5 or faster produces extremely high levels of heat. As a result, new materials, sensors and electronics are required to withstand such speeds throughout the journey. These systems must be able to maintain reliable communication connections as well as sufficient intelligence to perform precise maneuvering tactics to overcome a wide spectrum of advanced defense systems and extremely contested areas, according to the report, at least in the early phases of their flight path. Hypersonic boost glide vehicles aren't all that unlike from the warheads on conventional long-range ballistic missiles. Similar to conventional ICBMs, they are propelled into the upper atmosphere by high-velocity boosters, so usually to a lower altitude. The missile then releases one or more glide vehicles which use thrusters that may be maneuvered or momentum and control surfaces to manage the rapid drop as they approach their targets. These are the only hypersonic weapons that are currently in use by any country. Examples include the DFCF anti-ship weapon from China and the Avant-Garde nuclear boost glide weapon from Russia, while the US has pledged to only develop conventionally armed hypersonic missiles. Both of these weapons are regarded as nuclear capabilities. Boost glide weapons are entirely different from hypersonic cruise missiles like the Hawk. Instead of gliding at great speeds from great altitudes, they use a sophisticated propulsion system known as a scramjet for powered flight. A scramjet, also known as a supersonic busting ramjet, is a ramjet that uses supersonic airflow to ignite combustion. Due to the fact that scramjets are only effective at high speeds, these missiles are frequently launched from swiftly moving aircraft or employ an alternative kind of propulsion such as the rocket booster used in the most recent Hawk missile test to reach their desired speeds. In addition to numerous parallel initiatives in boost glide vehicles and scramjet-powered cruise missiles, the US is approximately 70 hypersonic weapon systems in various stages of development. America's attempts have, however, been sluggish and fraught with failure. Over the course of the last 12 years, there have been 17 tests of hypersonic weapons in total, and 10 of those tests have failed entirely or partially. Although many scramjet attempts have failed, this hasn't always been the case. Instead, technical issues with unrelated support systems, including rocket boosters, have often been at blame. Despite having a reputation for being behind in hypersonic technology, the U.S. may really be the front runner when it comes to scramjet systems. According to the success of a second Hawk missile design, scramjet technology has proven to be extremely difficult to develop, in large part due to how difficult it is to maintain combustion while air is moving through the engine at Mach velocities. This difficulty has been compared to trying to keep a candle lit amid a cyclone in terms of its nature, and that's going to do it. Last month, the United States successfully tested a scramjet-powered hypersonic cruise missile, and unlike the Kinzhal that Russia recently used in Ukraine, this weapon was the real deal. Now, hypersonic weapons are new weapons that can travel at speeds faster than Mach 5, but it's really their maneuverability that makes them special. Let's dive into America's latest hypersonic cruise missile test. Hypersonic systems provide a combination of speed, maneuverability, and operating altitude that enables highly survivable long-range capability for the rapid defeat of time-critical, heavily defended, and high-value targets. Now, something that's really important to note about this recent test is that it's the second successful test for the DARPA-led Hawk missile effort, but it was the first using a Lockheed Martin-sourced a scramjet propulsion system. The last successful test was actually of a Raytheon-built Hawk missile powered by a Northrop Grumman-sourced scramjet. Now, what that really means is that the United States now has two working scramjet designs for missile applications, and that's a pretty big deal because although scramjet technology has been the subject of study for literally decades and there have been plenty of scramjet technology demonstrators over the years, no nation has ever fielded an operational scramjet in a weapon or a vehicle of any kind. Now, scramjets or supersonic combustion ramjets are sort of the next generation of ramjet technology that allows combustion to take place with air flowing through the engine at supersonic speeds. Now, where a normal jet engine uses a compressor section with fan blades to compress air prior to combustion, a ramjet actually uses the pressure of the air flowing into the engine for compression, and a scramjet works in a similar capacity, except ramjet technology uses a cone to slow the speed of the air flowing into the engine to subsonic speeds to make it more manageable for combustion. A scramjet, on the other hand, allows the air to travel through the engine at supersonic speeds, and as you might imagine, it's really tough to ignite an air-fuel mixture. When the air is moving at Mach speed. Earlier this year, I spoke to Dr. Joseph Jewell, who's an assistant professor at Purdue University School of Aeronautics and Astronautics, and he also happened to spend 5 years at the U.S. Air Force Research Laboratory's Hypersonic Sciences branch, and he had probably the best description I've ever heard for what makes scramjets so tough. He likened scramjet combustion to trying to keep a lighter lit in a hurricane. Now, other than this advanced scramjet propulsion system allowing for incredibly high speeds, the Hawk would travel just like any other traditional cruise missile, or really aircraft for that matter. In a way, you can sort of think of cruise missiles as suicide drones. They fly a lot like airplanes along a pretty horizontal flight path with the ability to maneuver to avoid being intercepted. We don't know exactly where the test was conducted, but it was somewhere off the west coast, and the missile was initially powered by a conventional rocket booster, as is often the case with scramjets because they just don't work very well at lower speeds. Now, there are no available figures for the Hawk's top speed or range. But reports from Lockheed Martin and DARPA both indicate that this recent test was conducted at moderate hypersonic speeds, which means probably just above Mach 5. The missile flew at an altitude higher than 65,000 feet and traveled a reported 300 miles an hour at these speeds. That means it probably only needed to be flying for about 5 minutes. Now this test is of particular import because with all the talk about the United States losing the hypersonic arms race, this scramjet test means the US has now had more successes than failures when it comes to testing hypersonic cruise missiles. Now, hypersonic cruise missiles are different than the hypersonic boost glide vehicles that both Russia and China have in service. Hypersonic boost glide vehicles aren't all that different from the warheads on traditional long-range ballistic missiles. At least in the early stages of their flight path, they're carried into the upper atmosphere via high-velocity rocket boosters, just like an ICBM, but usually to a lower altitude. The missile then deploys one or more glider vehicles that rely on momentum and control surfaces, or maneuvering thrusters to manage their high speed gliding descent as they close with their targets. Now to date, these are the only types of hypersonic weapons anyone has in service. Russia's avant-garde hypersonic boost glide vehicle is a nuclear weapon meant to be carried aboard their Rs-28 Samet, a new ICBM that should enter service later this year. Hypersonic missiles. China's DF-ZF is an anti-ship weapon carried aboard their DF-17 ballistic missile. Hypersonic cruise missiles, like America's recent Hawk test, fall into a completely different technological category. They are really only lumped together because they move very fast and can maneuver in flight. Now America's real secret weapon in the hypersonic arms race is, you guessed it, a whole bunch of money. America has over 70 hypersonic weapons programs in various stages of development, with a number of parallel efforts in both boost client vehicles and scramjet-powered cruise missiles, but America's efforts have been pretty slow going and honestly rife with failure. Out of 17 total hypersonic weapons tests conducted over the past 12 or so years, 10 have been either partial or complete failures. But it's important to remember that a lot of the failures associated with scramjet efforts haven't been about the scramjet at all, but rather technical difficulties with unrelated supporting systems. By my count, this is the 8th time the United States has tested a hypersonic scramjet-powered cruise missile, and of those 8 tests, 3 were failures, but 2 of those failures were because of either the conventional rocket booster failing to fire or a control fin on the missile failing to function. Only once out of those 8 tests, from what I've been able to determine, did the scramjet itself fail, and now we know that the last successful Hawk test launch, which took place last fall, was of a Northrop Grumman scramjet, and this most recent success in March was from a Lockheed Martin scramjet design. Now, depending on how much stock you put in Russian claims about their own weapons testing apparatus, this really may mean that the US is now leading the way when it comes to scramjet-powered hypersonic cruise missiles, and to be honest, that's in keeping with assessments that I keep hearing from experts and that we've discussed on this channel before. The hypersonic arms race you see in the media isn't real. It's all about who can claim to have these weapons operational first. The real arms race that's going on right now is all about who can field new capabilities that offer genuine strategic value, and in that regard, to be honest, China is in the lead with their hypersonic boost glide anti-ship weapons. But with this development in the US's efforts to field scramjet-powered hypersonic cruise missiles, they may not keep that lead for long. But I can already hear people in the comment section screaming about Russia's 3M-22 Zircon scramjet-powered hypersonic cruise missile, which according to them they have tested repeatedly and were practically done with testing by the fall of 2021. The problem with Zircon is that all we have to go on when it comes to whether or not this system works is Russia basically just saying that it does. Now, I understand that that's not all that different than just trusting press releases from Lockheed Martin or DARPA, but the truth is it's very different. You have to consider historical precedent and the media environment of these two nations. Russia has a long history of exaggerating military capabilities to garner media attention, and Russian state media controls the messaging both domestically and internationally. There is no free press in Russia to hold them accountable for their claims. The United States has been pretty open about its failures. I can read a list of them for you right now. You won't find that same sort of transparency coming from Russia or China, and it's because of that history of transparency and public accountability that I tend to trust announcements made in U.S. media or by U.S. agencies much more than I trust announcements made by the Kremlin or the Chinese government. For all of the egregious failings in American media, it is still free. You'll find lots of stories right now about the F-35 program being a failure, but you won't find any in Russian media about the Su-57 being garbage, and you won't find any in Chinese media about the J-20 not living up to expectations either. This isn't because the F 35 is much worse than these jets. It's because in America we get to talk about what our government is spending our money on and even complain when we don't like how they are doing it. But skepticism is a good thing. After all, the US has gotten beat up in the press over the past few years for losing this hypersonic race, so there's certainly incentive for exaggerating or even lying about successes. So I'll leave it up to you. I tend not to trust Russia's assessments of its own military capabilities because I've watched them lie so frequently and egregiously about it, but maybe their 3M22 Zircon is the exception. If that's the case, Russia may well put their hypersonic scramjet-powered cruise missile into service before the U.S. manages to get its own, especially because Russia really hurries to put things into service.